All right. So I want us to do that pre-assessment or go over the pre-assessment in more detail. So let's use a different marker because that one's hard to see. So here's something to keep in mind. I'm asking you to solve this equation. What does that mean, Hayden? What does it mean to solve this equation? Find the x. Hey, go. Pay attention. When we're having the whole class discussion, this is the time to pause and pay attention to understand. Now, and please hear me very clearly on this. A lot of us are getting tripped up. Yes, ma'am? We're going to talk about that part in a second. We're going to get there. But guys, hear me clearly on this. Listen, most of us are getting caught up on getting the number instead of understanding how and why. You have to understand how and why first, and that's going to get you to solving the problem and finding the answer each time. And so Hayden said finding x. But what do we mean by finding x? Z, I need your headphones out, please. So we want the variable x just on one side? That's it? That's all that matters?
Yeah. Basically.
Let me point this out. At the end of solving, we need a solution. At the end of solving an equation, you need a solution. So what is a solution? Like, could x equal 1 for this equation? Yes, no, maybe so? Any ideas? Miracle? Do you know how we can check to see if x equals 1 is a solution? Because I want you to engage in thinking. We're not thinking.
Don't you plug it in?
Okay. What's the more mathematical term for plugging in? Substitute?
Yeah.
Right? What would I substitute 1 in for? X? Okay? Let's see. Even if we don't understand like why we're doing that, let's just do this really quickly. And you can do this by hand, sure, but pick up the calculator. Pick up the calculator, type that equation into the calculator. Yes, Jamarcus.
I thought you would combine like terms.
Yeah.
Oh, well, hold on. Pause, guys. Pause. And good question, but for all the people who are starting to talk, pay attention. I'm not solving right now. All I'm talking about is what is a solution. I'm asking, could x equals 1 be the solution? That's all I'm asking. Because we need a better fundamental understanding of what a solution is before we start trying to solve. Okay? It says what? False. So could x equals 1 be the solution?
No.
Because what does a solution need to do to that equation? It needs to make the equation true. Okay? Haley, you had a question? What's up? But, say it one more time. Well, no. You're thinking about the solving process. I'm just asking, could 1 be a solution? That's all I'm asking. I'm not saying this is the answer, or this is the solution. I'm asking, could 1 be the solution? And we're saying that when we put this into the calculator, when we type this in, it's telling us what? It's telling us false. So 1 can't be the solution. Because David, you said earlier, what do I want the equation to be? I want the equation to be true. Please understand, the whole solving process is to find a solution. So often, we say that the solution is the answer. The solution is the x on its own on one side of the equation. But we're missing the point that a solution is what makes the equation, or makes the inequality even, true. And so the reason why this is important is, can I have a solution to an equation like this?
Yeah.
Does anyone know how many values I would need, though, to have a solution?
2.
I would need 2. For instance, let's say I look at the point 1, comma 0. What could this 1 be substituted in for? And the 0 would be? So does 0 equal 3 times 1 minus 5? No. So is that a solution? No. What about the point 2 comma 1? Now at y would be 1, x would be 2. Would that be a solution? Yes? I know you're looking at me like, Mr. King, why in the world are we doing this? We're going to get there in a second.
It's crazy, I don't get what you did. Y'all gotta go around it like that, like, you just can't combine like terms when you work on one side. No.
Because if you're solving and you don't understand what a solution is, how are you going to know if you have a solution? And we're not fully sure of how to solve. And like, I need y'all to understand this. Like, if you don't understand how I'm doing this, cool, ask a question. But we're coming in saying that most of us don't fully know how to solve that equation. So we don't know solving. Like, trust me that this is fundamental to solving. If you're going to solve, you're supposed to get a what at the end? And what is a solution? It has to make the equation or make the inequality true. And so, I'm just pointing out, if I have y equals 3x minus 5, can I have a solution? We found one, right? Yes, Mr. King, thanks guys. So, what about 5 comma 10? This is the last one I'm going to do like this. Notice now y would be 10, x would be 5. Is 5 comma 10 a solution? Yes. 15 minus 5 is 10. When it comes to equations with 2 variables, do you know how many solutions there are? We just found 2. Any guesses how many equations or how many solutions there are? By the way, do we recognize this type of equation at least, hopefully? What is it? Slope-intercept form of a linear function, right? Slope 1, 2, 3 to the right 1, up 1, 2, 3 to the right 1. Hey, what's that point right there? 2 comma 1? You mean this point right here that was a solution? If I were to graph this line here, you know what other point this line would have to go through? 5 comma 10. When we graph a function, every point on that function is a solution. So when we have 2 variables, how many solutions are there? There's one here, one here, one here. Heck, there's one here, that's why it's a line. One here, 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 continues up here. How many solutions are there? A lot. Not just a lot. Say it again. Infinitely many. When you have 2 variables, the solutions are infinitely many. But when we have an equation like this, how many solutions are we going to have at this point? There's only going to be 1. But that's not always the case. That's why I'm bringing this up. We have to understand what a solution is. The solutions are every value or values that make the equation true. And we're used to cases like this where there's only how many solutions? 1. But that's not always going to be the case. And so we have to go into it understanding that a solution is not the single answer. The solution is all the values that make that equation or make that inequality true. Now, let's talk about how to solve this. So what was the first step that so many of us were paying attention to? Say again. Combining the like terms on just the left side. Now, I'll point this out. Eliza, you didn't add like terms to start, did you? What did you do first?
I did. Let's see, yeah, right here, on the 15.
Okay, so added 17 here and added 17 here. Is that legal? Is that okay instead of adding my like terms? So hear me clearly on this, guys. There are lots and lots of ways to solve equations. So I can't tell you the one way to do it every time. but you have to understand how and why things work so that you can apply it in any way you want. If we follow, so I'm going to show it both ways. You don't have to do both ways. It's going to help us understand these equations. But right here, when I add 17, what's the goal there? To create a 0. Negative 17 plus 17 is 0. Hear me very clearly. I cannot do negative 17 plus 15. Those are on different sides of the equation. If they're on different sides of the equation, I can't do anything except I could make this a 0, and whatever I do to one side of the equation, I have to change on the other. To keep them equal, what I do to one side of the equation, I have to do it to the other. And so I want you to notice this. Does this equation look exactly identical to the original? There's no longer a minus 17 on the left-hand side, is there? So they don't look exactly the same, but do they mean the same thing? So what would we call those equations? Equivalent. They look different, but they're the same. Those properties of equality allow us to create equivalent equations. I'm adding 17 to both sides. A lot of this we're saying 3x plus 2x. To create a 0, you have to do things on both sides of the equation. But if they're already on the same side, I'm just adding them together. What's 3x plus 2x? 5x. Why? Okay, but why would 3x plus 2x give me 5x? It's not just because it's 3 plus 2 is 5. It's not just because it's like terms. We've talked about this. What does this really mean? Well, it's how many times we multiply. It's not how many times we multiply. It's how many times the x is being. Multiplication, guys, is repeated addition. So what does this actually mean? I'm doing what with 3x's? I am adding. This is important because later we're going to get to something like this. I still have 3x's here, but what am I doing with those 3x's? Multiplying. I'm not repeatedly multiplying here. I am multiplying, which is repeated. So if I have 3x's being added there, and then what am I doing here? Adding 2x's. Okay, how many x's is that? That's 5, right? It's not just, hey, it's 3 plus 2, and this is important for what we're going to study later. It's not just 3 plus 2, it's I'm adding 3 x's, and then I'm adding 2 more x's, gives me 5 x's. But it's not just 3 plus 2, because can I do 15 plus 7? Why not? But I can do 15 plus 7. Why can't I do 15 plus 7x? So why can't I add them? This is the... But see, if you just say forever that they're not like terms, you're going to make a mistake because it's not... why can't I add them if they're not like terms? You've memorized a process without understanding why I cannot add those. It's not just because they're not like terms.
You solve for the.
Yeah, I'm solving for x, true, but why can I not add them? I already told you. If we pay attention to what we just talked about over here, this informs why we cannot add 15 plus 7x.
No, I know you can't add 15 plus 7. I'm saying like,
I know what you're saying, but what I'm saying tonight is, I already explained, if we pay attention to what we talked about with why 3x plus 2x is 5x, going back to why that works, that tells us why we can't add these. What are you thinking, Marshall?
7 is repeatedly added and 15.
7 or 15 is just that number, right? And I wouldn't talk about the 7 being repeatedly added. You can, it's just going to be a little bit more complicated thinking that way. What is being repeatedly added? What's another thing to think about? X. Hey guys, can I do 15 plus x? Do I know what that is? So can I add 15 plus 7x's? Is that something I can do? it's not just that they're not like terms. I can't do 15 plus 7x and get 22x because 22x literally means that I'm adding x how many times? Do I have 22x's being added here? That's why like terms or unlike terms can't be added because they're not the same thing. I have 15 and I'm adding x 7 times. Those aren't the same. I can't do 15 plus x, that's the whole issue. So it's not just that, hey, they're not like terms. It's because I can't do 15 plus x plus x plus x. I don't know what that is. That wouldn't give me 22x. Now, from here, or from here, actually I guess here we already did 3x plus 2x, and I do like what Eliza did. So coming back to here, I know that we've talked through several things, and we'll take direct notes on this. I'm just explaining background so tomorrow's easier. 3x plus 2x, or not that, sorry. When Eliza added 17, whatever we did on one side, we had to do to the other. This makes it more clear. For those of us who are trying to add things from the other side of the equation when we can't yet, this makes it very clear. 3x plus 2x is what? 5x, right? I have 3 x's, I'm adding 2 more x's. When they're right next to each other, it's easier to recognize that that's a 5x. The reason I bring that up, and it's such a focus for me, is I cannot tell you how many times this is what I see. Minus 2x and minus 2x. What's the issue here? It's on the same side. What I do to one side of the equation, I have to do to the other side of the equation. The whole idea is that I'm balancing that equation out. If they're on the same side, I'm not going to use an inverse, I'm just going to simplify. And we're going to talk through those terms and define those things tomorrow. But we have to be clear on our language of what it means to be a like term, what it means to simplify, and what it means to use an inverse to solve an equation. Okay? What would I do here at this point to finish solving this equation? I added 17 to create this 0 so that I don't have any constants on the left-hand side. What do I not want on the right-hand side?
7x.
Okay, so let's talk through the two different things Marshall and Tevin said. Either I subtract 5x, or Marshall, you were thinking that I should subtract what?
7, keep it on the other side.
Okay? We have to be careful. This is a very common thing that students do, right here. And what students would write next is 32 equals 2x. But actually read what's here. What is 5x minus 5x?
0.
0. This is actually legal, but you have to pay attention that the left-hand side would now be 0 equals 32. 7x minus 5x is plus 2x. That's legal as long as we recognize it be 0 on the left-hand side. This would create more work for me. I'm going to come back to this in a second, Tevin. What's 7x minus 7x? And what I did on one side of the equation, I did to the other. 5x minus 7x is? Now, Tevin, if I'm looking at this, I need my variable on one side, and that needs to be on the side opposite my constant. So I'm going to create a 0 here. You see how that gives me the same spot at this point. But we have to be careful that we do it the right way to make our job easier and that we don't get 32 equals 2x, because that's not right. From here, I'm still going to use my reciprocal. Y'all can divide if you want. I would prefer you, because it's going to help you with exponential functions, to use that reciprocal to solve. Notice, what is this fraction bar again? So what is negative 2 divided by negative 2? So when we add and subtract, we're creating zeros. When we multiply and divide, we're trying to create a 1. So x is equal to 32 divided by negative 2 is negative 16. So those who got that negative 16, that's what we're looking for. We've got to understand simplifying, how to use inverses, like terms, and what a solution means. how could I check to know that that is in fact my solution at the end?
Like,
Say that more mathematically.
replace X and substitute.
What do you say?
What?
Substitute. Remember, if these things are equal, then I can substitute negative 16 in for x. Guys, I know that y'all are going to get tired of me trying to correct the language, but incorrect language is going to cause confusion for you down the line. Language matters, and you can say, you know what I'm trying to say, but do you actually? If you can't fully explain it, if you don't have proper vocabulary for it, it's going to cause you errors down the line. So we got to work on that language. Substitute it in. And please hear me very clearly on this. In the nicest way possible, a lot of teachers are not accurate with their mathematical language, which is causing us issues now. That's a problem. A lot of math teachers are not precise with their mathematical language, which is going to cause us problems now. I'm going to try to correct that. But we already typed this in, substitute that negative 16 in for x. What does it tell us? So we got a true. Can I get a couple more confirmations? True. Okay. So, if it's a solution, it needs to make the equation true. Questions, comments, concerns? Yes, sir.
I wasn't paying attention. You did move from left to the right, didn't you?
I'm trying to think about how you're meaning it. Can you clarify that question?
Because you was working on both of them, so I had you feel me?
So I worked on both of them because I didn't finish this one. I can finish this one in a second. I mostly focus on this right-hand side over here. The point is that if we simplify correctly and use our inverses to create zeros, right? So I could do minus 5x here to create a 0, minus 5x here, and so 0 minus 17 is negative 17 equals 15 plus 2x. Then I would need minus 15 here to create a 0. If I'm focusing on this idea of creating zeros and ones and simplifying, I get the same answer, or the same solution. Does that answer your question? Okay. I just didn't finish this one, but if you finish it, notice it doesn't matter which method I choose, I get the same solution. There's beauty and flexibility within mathematics. You don't have to do it one single way, but you have to follow the rules correctly. You have to understand how to simplify, adding those like terms, but what does that actually mean? You have to understand how to use your inverses to create zeros and to balance out that equation. But there's lots of flexibility within that. What are your lingering questions with this intro into solving equations before we continue with today? All right. Let's look at our agenda. That's not what I meant to do. All right, in this class, I believe we already talked about what we have learned so far. I mentioned this yesterday, and I did not get further in grading last night because I had to lead community group at church, and so by the time I got home it was 8:30 and Alex was already ready to go to bed for sure. So I didn't get further in grading last night. But from what I've graded so far, it's not been pretty. Okay? We don't know these two major ideas, or some of us don't know these two major ideas. Your last chance to show me mastery of those things is your midterm. Midterms are the week before spring break. So that's the 9th and the 10th, I believe, of March. That means you have 2 weeks from today to come into tutoring hours, to come in, to watch the videos on YouTube, to do what you need to do to master these concepts. Because I'm going to use your midterm to reassess. And it's not too much. I know some of us are already saying, already have thought, and I've heard us say it's too much. We came in with a a bad attitude about it. We were already upset, and we did not give ourselves the best chance to learn. But you are all capable of growing and learning. And I talked about it yesterday. What are the 3 patterns that we have studied so far? Linear, exponential, and quadratic. We need to know what makes each of those patterns, those things. Linear, constant additive. Rate of change, called a slope. Exponential, constant multiplicative. Rate of change, called a constant factor. Quadratic, linear, additive. Rate of change. We need to know what those would look like in tables. We need to know that if it's a linear function, the graph is going to look like a line. An exponential looks like an exponential curve. A quadratic looks like a parabola. You got to know those things. Notice, these are some of the major things that I tested you on, and there was even a graphic or a Venn diagram where you're supposed to fill this information out. We got to know that. That's like the bare minimum we got to know. And then within those 3 patterns, we learned 5 equations. What was that equation for a linear function? Y equals mx plus b. What was the equation for that exponential? Y equals a times b raised to the x. And then the quadratic, we had 3 different functions. Or 3 different equations. We got to know them. We got to know our standard. Y equals ax squared plus bx plus c. We've got to know our factor. Y equals a times x minus r1 times x minus r2. And we've got to know our vertex. Y equals a times x minus h squared plus k. If you can't even write out those things, guys, those are the foundations, those are the basics. If you can't identify those things, you've wasted 4 weeks of your life. That's how long we spent on this. Those things. And there's actually applying them. But you should be able to at least spit out that information. And then you have to know what these things mean. But that's what we study for 4 weeks. That's not too much. We've got to take the time and effort we've got to put in that time and effort to learn those rates of change, learn those graphs, learn those equations, and then know what those things mean. Because if you understand that, then applying this information is not terrible. That's it. That's what we focused on for 4 weeks. You're capable of learning that. Stop selling yourself short. Stop telling yourself it's too much. Because you have one last chance to show me greater mastery. I want you to be successful. But we got to put in the time and effort. And some of us didn't even put in the time and effort to do the mathiest stuff. You got to fix that. Alright, that's what we've learned so far. We're going to get new groups in just a second before we go back to the textbook with activity 4.3. Now, hear me clearly on this. Pause for 1 second. We are focusing on solving quadratic equations this unit. Notice how I said we're solving quadratic equations. That means we're going to be looking at solving equations like this. We're going to learn how to solve that. But that's why we did the bell ringer we did, because we have to have strong foundations of what does it mean to solve before we can solve a quadratic equation like that. And you also need a strong understanding of the different forms of a quadratic equation, because each form has its own best method to solve an equation. So we're going to take a little bit more time today working with these 3 forms to make sure that we are prepared for that next part. These are foundations that we need. So, go ahead and, I guess, don't get out your textbook yet. Let's find our new groups. Random list. Where's that list? There it is. Alright, there's our list. Lily Kate, Shania, Jacoby, Jalen in group 1. Rakai, Grace, Naisha, Eliza in group 2. David, Sanaya, Haley, and Hayden in group 3. Preston, Tyson, Mickey, Jamarcus in group 4. Z, Ethan, Marshall, and Desiree in group 5. Phoebe, Kevin, Cam, and Miracle in group 6. Treyana, Jose, Jayla in group 7. Okay, so don't forget, these are where each of those groups are going to work for their vertical surfaces. But let's get to the actual lesson that we have. So as I mentioned, right, we've got to know our equations and know when they are those forms well before we can start to solve them. And so with that, who can read our first objective for us? Eliza, or our objective?
I can work with
Sorry. Key features given, right? We did not write quadratic equations last unit. We are going to write quadratic equations with this unit because we need to be able to do that in order to solve equations. So here's where we are in the book. We already talked about this a couple of times. Are you sure? What's she doing? Whose work? History work is to be done in history or at home, not in the middle of my math class. So, we talked about this before. George and Pat, they have a vertex of 4, 8. So what form of the equation did they use? If they have a vertex. They use vertex form. If we've got a vertex, we're going to use vertex form. Notice, did they both write an equation with that vertex correctly? Yes. They just have different A's. What we want to recognize is that you can write an equation with a vertex very easily, but we're going to have to learn how to find the A. And this is when you can find the A. So by the way, we're on page M1-60. Now you should have the book with you. Shania? What you doing? Shania? What? Let's get our book out, pick our head up. Even if we don't have our book, guys, we can still pay attention and learn something. But we should have our Volume 1 textbook. So M1-60. Notice, and well, I'm going to move through this quickly because here's an example and we're going to apply this throughout today. But we have a vertex, so what form are we going to use? Vertex form. I would, first off, do what if I know I'm going to use vertex form? I'm going to write out that equation every single daggone time. Too many of us don't even know our equations. Write it out. It's going to help you learn that equation. So Hayden, what is the vertex form equation? F of x. There's my vertex form. And one, that's going to tell me, hey, that's what I need to find, right? Jayla, what 3 things do I need to find in order to write that equation? I need A, H, and K. Anybody know any of those 3 right away to get us started? Does anyone know A, H, or K? H is 5. K is 2. vertex, h comma k every single time, right? So if I'm looking at this equation, Jalen, what could I go ahead and substitute into this equation? You have no idea. Which numbers? Okay, right. For what? What would 5 be substituted in for? Look at how we labeled it. Remember, a vertex is h comma k. So it's going to go in for h. Notice, I have the majority of that equation. What's the only thing I'm missing? The a, right? Oh, did you say x, Tom? Remember, x is a variable, guys. I'm going to leave an x there, right? I always leave x and I always leave f of x because those are my variables, but I need to know those other values. I need to know a. Because I have another point, though, I can figure out what a is. Points are always labeled using what letters in general? X and y. So Miracle, what could 4 be substituted in for?
No, I can't see that.
It's in your book too.
Oh, we're looking at.
We're looking at the bottom left-hand side, example 1. Or worked example.
X.
Uh-huh. 4 is the x value. So this x right here can become a 4. Now Marcus, what could this 9 be substituted in for?
Wait, I don't know.
Is it labeled as a right here?
No, label is Y.
Every point is x comma y. So it's going to be substituted in for
Y.
y. Now, this is a slightly tricky part, but where do we see the y in this equation? F of x. Remember, f of x, that's my output. That's my y. Hey guys, how many variables do I have in that equation? Or let me rephrase that. How many unknowns do I have in this equation? 1. What is it? A. So we're going to have to solve this equation. Let's see, someone I haven't heard from yet. Z, do you know what I can do first to solve this equation at this point? No. No idea? Have you taken any time to think, or you just immediately saying no because it's math and you don't want to? You gotta at least try, guys. Marshall, any ideas what we can do to get started?
Subtract 2.
Okay, can I subtract 2? 2 minus 2 would be 0. That's perfectly legal. That's actually not what I would have done first, but it works, right? I created a 0. So here's the thing, and there's a difference. Sometimes if we're using inverses, or we can simplify. But so this is an alternate way to do it. This is what I would have done first. But as long as I follow the order of I follow legal rules, I'm good. What is 4 minus 5? -1 squared plus 2. Right? I'm going to continue this way, and I'm going to go back to the way Marshall was doing it. What is the next thing I could do? Well, I don't need to distribute, and I will remind you, a is being what? Multiplied. What happens first, multiplication or an exponent? What's the order of operations? What comes first? The exponent comes before. Remember, exponents are repeated what? Multiplication. I got to do my repeated multiplication before I can do multiplication. So what is -1 squared?
1.
-1 times -1 would give me a +1. Now what would be my next step?
Subtract 2.
Oh yeah, so I would have subtracted 2 at some point, right? 9 minus 2 is 7. By the way, what is a times 1? Not 1. A times 1 is A. Literally, that's 1A, isn't it? So A is 7. Let's go back to the way Marshall is doing it. And I know some of us are going to get frustrated. Like, Mr. Kenny, just tell me one way to do it. No, because it's flexible. There's options. There's beauty in whatever way you approach, as long as you understand the rules. that do like work. I subtracted 2 to create a 0 and I did it to both sides of the equation. Now I have 7 equals a times 4 minus 5 squared. What would I have to do next? I'd have to do what's inside those parentheses. 4 minus 5 is? Negative 1. What's negative 1 squared?
1.
And then a times 1 is? Did that give me the same answer? This is the beauty of mathematics, that there's more than one option. It's whatever you see, as long as you understand that when you create that 0, whatever you do to one side of the equation, you have to do to the other. That you can simplify and paying attention to that order there. And so notice how they got a equals 7. Now remember, and always go back to, what are we trying to do? We're trying to write the equation, right? What is A now? 7. What is H? And what was K? Doing this work is going to help us practice solving equations. It's also going to help us practice the forms of quadratic equations. Those are 2 things we need. Okay? Doing this work is going to help us develop our understanding of solving equations and the forms of quadratic equations. But we need to engage and we need to pay attention and get going with this. What are your questions about this worked example before I continue? How or why things worked, how I got certain numbers. Yes, Teb?
For that 7 equals 8 in parentheses negative 1, how do you get like the positive 1%?
Are you talking about right here?
Yeah.
So, don't forget, one, you can use calculators to help solve, but when you square something, what does that mean?
All of them to negative.
Right? I'm multiplying it by itself. Right? Do notice though, that's why you want to put in parentheses. If y'all type in, and please do this because this is actually important. If you were to type in negative 1 squared, just like that in your calculator, what do you get? Did you already try it? So everybody, pick it up. I do want you to see this though. If you type it in just like this, what do you get? Negative 1 squared, just like this, without parentheses. Negative 1. It's not because your calculator is broken. It's because your calculator fully understands the order of operations. What this is saying is the opposite of 1 squared. Well, what is 1 squared? What's 1 squared? 1. So the opposite of 1 squared is negative 1. That's why the calculator is spitting that out. But if you type in negative 1 squared in the calculator, type in negative 1 squared with those parentheses there. Positive 1, right? Your calculator understands the order of operations. Be careful with that to make sure you type things in correctly. One recommendation that I will give, okay, you do whatever you want on this as long as you show your inverses and your properties of equality. I recommend simplifying before using inverses and properties of equality. Okay? I do recommend that you simplify first before using inverses and properties of equality. Do I need to clarify any of that language? Jose, you good back there? Looks like you're trying to fall asleep on me. So I don't need to clarify any of that language, you good? Huh? No, you're not good, or no, I don't need to clarify? I'm literally giving you chances to ask questions. If you don't understand that language, you need to ask it, because that is mathematically accurate. That is what it's called. Okay. Last one before we work in our small groups a little bit, okay? Notice in the second worked example on M1-61, what are you given? Well, you're given the, what does it say? In that quadratic function, we're given the roots. Because we're given roots, what form are we going to use? Factored form. So Naisha, what is our factored form?
F(x) equals x minus R. No, that's, yeah. Parentheses. Parentheses, x minus R.
Okay. All right, we good to
R
go?
and A.
Right. Don't forget we need that A in there. So, what things do I need to write this equation? This is why you want to write that equation out. Rakai, what things do I need to write this equation? If we look at that equation, what things do we need to be able to write that equation? R1, R2, is there anything else? And A. We need R1, R2, and we need A. Those are the three things we need. Do we have any of those yet? We have R1 and we have R2. We have roots, right? So right away, I can start to write this. This would be, I don't know A yet, but this would be what for the first set of parentheses? Remember, we need the X. And y'all said X plus 2? Minus 2? So let's resolve this and talk about why. Why are you saying plus? Do we need the opposite with these? Right. Remember how with x minus r1 we need that opposite value? And it's coming from, and you're right, Jose, it's two negatives. It's x minus a negative 2. Right? X minus r1, x minus that negative 2, and when we subtract a negative, it becomes addition. Times x minus 4. This is going to help us again. Practice writing quadratic equations and knowing the forms. And then we're going to get into the a value in a second, because I don't know what a is, but do I have any other information? Say again. I have an x and y. I have a point, right? So I can use that point to be substituted in for x and y. So what's being substituted in for x? 1. What's substituted in for y, or f of x? 6. So 6 is equal to a times 1 plus 2 times 1 minus 4. Mickey, how many unknowns do I have in that equation? What is the one unknown? And I need a, don't I? Just write that equation? So Lily Kate, what would I do at this point to solve that equation? Add what?
Or add 4
To both sides of the equation?
to 2
Say, so like you're adding 4 because of this right here? Okay. One thing to be aware of is, and this one can pay attention to, you see how it's inside of parentheses? I can't use that inverse to add 4 when it's grouped together with the 1. The reason why, so I'll let you tell us in a second, Hayden, when we had this problem earlier of, what was the equation? Let's go back. It was 9 equals, okay? When it was 9 equals a times x minus, no, not x minus, 4 minus 5 squared plus 2. The reason why I could subtract 2 is it wasn't grouped with anything. You see how it's outside of everything else? So I can't add 4 because it's grouped with that 1. So Hayden, what were you going to do? Remember how I said simplify first? Can I simplify 1 plus 2? What is that? 3. So 6 equals a times 3 times negative 3. 6 equals, I'm going to continue simplifying. What's 3 times negative 3?
-9.
Is there anything else I can simplify? I mean, that is the same thing. I could rewrite it that way, but that's not simplifying. That's literally exactly the same thing, right? Okay. Well, remember, they're being multiplied, aren't they? When we write A and then we write parentheses and I don't write anything in between, they're not being added, they're being multiplied. So this is being multiplied all the way down already, so they're being multiplied. Remember, A times -9, that's the same thing as -9A because this is understood multiplication. Does that answer your question, David? Okay. Is there anything else I can simplify though?
Yeah.
What would I simplify? But notice they're on different sides of the equation, so I can't simplify them. If I have finished simplifying, what am I going to do? I'm going to use inverses, which in this case, the inverse operation would be division. Again, I'm going to use my reciprocal, 1 divided by -9. But -9 divided by -9 is 1. And I might use a calculator right here to simplify it. -1/9 times 6. -2/3. Yes, that using this reciprocal, right? 1, and then what's that fraction bar? No, the fraction bar. What does that mean? Divided by. So I'm dividing by -9. I'm going to continue using this reciprocal because it's important to recognize that that fraction bar means division is going to help you with exponential functions. So -2/3 is equal to A. That means I can substitute this -2/3 back in for A, and there's my equation. So this is going to help us practice with the forms of quadratic equations, and it's going to help us practice solving equations before we start solving quadratic equations. But today and tomorrow are the last days we're doing this intro, and then we're going to start solving quadratic equations on Monday. All right. The start to this is here then. Number 2, and I think we briefly started on this yesterday, and Ethan, you said with part A that you would use the standard form, right? Preston, why might Ethan say he's going to use the standard form here with A? Huh? Oh, let's wake up so we can learn. Desiree, any idea why Ethan might say to use the standard form here? Not sure? Jacoby, do you know why? We have the y-intercept, right? Which form uses that y-intercept? Or do we see that y-intercept in? In standard form, right? Here's the one thing I'm going to point out though. That would be my C here. Notice how this then would need to be my x and this would be my y. How many unknowns do we have in this equation? 2. Can't solve a single equation with 2 unknowns. Does that make sense? So let's look at this again. It's a great idea, y-intercept, so standard form. That minimum point, what else would that be for a parabola? Say that louder. Would the minimum be a vertex? If it's concave up, that minimum, would it be my vertex? So what form can we use if we have a vertex? I'm going to use vertex form. Hear me very clearly on this. Unless we're using technology to help us, I'm not going to ask you to write standard form. It's a pain in the butt. I am going to ask you to write vertex form, and I'm going to ask you to write factored form. Okay? So here's what I want us to do. I want us to get to our vertical surfaces at this point, and I want us to do B through G. Notice the directions here. Yes, Mickey?
Which one do you want 4 to go to?
Sorry, this is supposed to say groups 1 and 5 are on the side whiteboard. Thank you. Okay. What are our directions here? What are we supposed to do, Cam, for B through G? Cam? You don't know? Can you read the directions for us?
Max, it's a baseball.
Guys, if we aren't even paying attention to directions, how are we going to learn? Cam, my man, right? I'm literally pointing this out. Like, this is what I'm asking you to read the directions for.
Determine which form of a quadratic function would be most efficient to write the function using the given information.
Okay, identify the form that's going to be the most efficient. Standard form, factored form, vertex form, or even none are options. Guys, you don't have to have all these answers right. We're going to have a whole class conversation about this. I want you to take a couple of minutes right now, and I want you to identify which form you think would be best, and we're going to talk about it to make sense out of it, and you're going to have another practice problem with this. So, let's get to our vertical surfaces. Let's talk with our group, and hear me very clearly on this. If you're in a group and someone or the rest of the group says, hey, we should use this form, and you have no clue why, what should you do? Ask a question. And if you ask a question and they answer it and you still don't understand why, what should you ask for?
Mr. Kenny.
Help.
Not quite yet. Yes, Mr. Kenny, but there's only one of me, there's 7 groups. Ask him to reword it. And hear me clearly on this. If you cannot reword it in the way that someone else can understand it, then you don't fully understand it yet. Or they're just really struggling. That's when I can come over. And if you are asked a question, you help each other out. If you can explain it to the point where someone else understands it, you understand it as well. Talk with each other. Because the more you talk, whether you're on the side asking questions or you're on the side explaining, when you talk with each other about the math, you're going to learn it better. The conversations, the explanations are what matter the most. You can learn from error, but I need you engaging in doing something. So let's get up, let's move around the room, let's complete B through G. In just a few minutes, we'll come back together. Guys, don't forget you can bring your book with you so you don't have to look up the board. Y'all need an eraser? What happened to the other eraser? And here's one for y'all. Okay, I have to see what.
I think E is factor form. E in there.
What? You're not allergic. Alright. What are we talking about with B? They do give us points. Do they give us any kind of special points to know what form we use? Sure about that?
What you mean special point?
Well, if I'm, because here's the thing. Is there anything special about it?
It's like you can help with
They're X.
They already give us.
X-intercepts. Could that tell us one of the forms to maybe use?
So there's
The X-intercepts connect to what IP?
R2.
The roots. So if we have roots, what form form are we gonna use?
I got
That makes sense?
Yeah, I hope it. We don't have long.
Weeks. I mean, you throw it away.
Baseball.
So tell me, why did we say factor vertex?
Oh, no.
Can you tell me more about why you're doing
None of the spaces
So
provided.
like, what is it about having vertex here, that tells you to use factors or vertex? Okay, so when we say root stuff, what do we mean by that?
Space throughout it.
Oh. Right here. R1 comma what? R2 comma. What do we know about every x-intercept that's ever existed? Y is equal to. We have x-intercepts. We have groups, right? That's why I was asking that question. By the way, I'll say that you say vertex here. What do we need? We need a vertex H and K. Do we have that for sure? Does it think about those things? What questions do we have? Interesting. Let me point this out. This might help. What are those choices here? 3, 3. Would that be it for apple? Does that make sense?
What can we do without them?
It's both, it's okay. How we doing? Or you're writing that in the space provided. I got you. I was wondering what you meant by I was just confused. Wait, y'all know we're just identifying which form, we're not actually doing But so if you have roots like that, then what are you going to use? So then just write factors. Like you've got roots, so you can use factors. Not yet. We need to practice identifying these forms first.
Can I write something?
Okay, do this for me, hey, because of time constraints, skip C and D, focus on E through G. We'll talk about C and D in a second. How we doing? E and G are giving us, no, so I'll check on them with E. Damn, what? I was gonna ask about E.
It's like, it's simple.
Which one?
See.
It doesn't give us so we can't use factors.
Yeah.
So Genesis is calling me back.
That's fine. I was trying to do
Oh my God, they be a person in
Now, these are the people.
I can do it in my hand, but
I can do it in my head, but I can do it in real life too, just like.
I thought you could do it in your head.
We know how to do this stuff.
So on G, why are you saying factors?
No, I was listening.
Yeah.
Good, I've been saying it. Good, I've been saying it.
Tell her right there.
No, but I've been saying it though.
Alright, let's grab a seat, let's talk about it.
It said G on it. It said G, he said read G.
Alright, so talking about this, the first one, I see, or not first one, but B, I see all of us are saying factored form for B, but why are you saying factored form? I don't see anything about the language of roots, I don't see anything about the language of x-intercepts to tell me to use factored form.
You said,
We actually,
Just calm down.
Raise our hands to engage. Alright, let's start with Rakai. I thought Rakai was the one who started talking earlier, but I'm not sure. But go for it, tell us. Okay, does anyone want to add on to that idea that y is equal to 0, so that's the x-intercept? Anything else we can add with it? I will point this out. What is the x value of the x-intercept called? Anyone remember that language? Say it louder. Not h. Remember, h was the x value of the vertex, right? What was the x value of the x-intercept called?
X-intercept? Wait, was that right? Root. Oh, roots.
Roots.
Oh, I said it first. Gotcha.
The x value, guys, remember, the x value of the x-intercept is called a root. And we know that these are x-intercepts because the y is equal to 0. They didn't say x-intercept, but we have to recognize that if my y is 0, I've got an x-intercept, that means I've got roots, I'm going to use factored form. Okay? When I look at C, y'all are going to say none, and I get that, I told you to say none there. It's possibility that we could use standard form, but am I ever going to ask you to do standard form? No. So it would be none, okay? I'm not going to ask you to do standard form without technology. I'm actually going to, next Friday is the plan, I may have to rearrange it, but next Friday, a professor from UWA is going to come in and we're going to do some activities where we're looking at, what?
A professor's gonna come in?
Yes.
What day?
The plan is next Friday. He is going to be bringing in interactive things that, yes, I talked about this already. It's kind of like a roller coaster effect where we're going to be pushing balls down the roller coaster. We're going to collect data because he has a motion, I forgot the name of it, but some kind of motion machine that can track the height over time, and it's going to allow us to explore quadratics more. It's not a professor lecturing to you. It is a professor bringing in things that I don't have to help us explore quadratics better. Okay? He's an astrophysicist, so his background is in physics, right? So he's going to bring in physics-based concepts to help us talk about math. And this is something to remember. Math is not just some random rules that someone created. Math was developed and discovered to understand the real world and to give language to the real world and how things operate. Tevin, iPad up. So, keep that in mind. Alright, part D. Now, I do want to point this out. Part D is definitely none. There is no standard form here. And we talked, and I think everyone said that, but I want to point this out from this group over here. We looked at these points. What's the first point given to us? 3, 3, then 4, 3, then 5, 3. What does that create? A line. Specifically, it's creating this line, and the equation for that line would be y equals 3. Because what is every y value here? 3. When we have horizontal and vertical lines, we're going to have one value in common. Notice the y value is always 3, so that equation would be y equals 3. So can we write a quadratic equation here? No, right? That's why it's none. Picturing points and seeing how things look on graphs is helpful to understanding these things better. E and F, we felt pretty good, factored form. Very clearly told to us x-intercepts and roots. And then a lot of us weren't sure at first with G, but I think everyone got to vertex form. What key word told us vertex form here?
Maximum.
It's a maximum. If I have a maximum height, what do I have?
I mean, yeah,
So some of us had a lucky guess, but notice if it's a maximum, I have the vertex. And a vertex means I'm going to use vertex form. Okay? Do you understand why now? Yes or no? Maybe so.
Yes.
I mean, do you understand that that maximum is a vertex, or we're going to use vertex form?
Yeah, that works.
Okay.
Yeah, somewhat.
You can picture it, right? You see that maximum right there?
A little bit.
Okay. Final questions about these forms before we continue with today. I will point this out as a final note that you may want to make to yourself. If you have roots, what form are you going to use? So if I have roots, which means I have x-intercepts, I'm using factored form. If I have a vertex, I'm going to use vertex form. That's the big picture idea, right? We have individual examples here, but the big picture idea is if I have a vertex, I'm going to use what form? Vertex form. If I have roots or x-intercepts, I'm going to use factored form. That's it. Those are the foundations. But that does mean we need to know our forms. If you still have not learned those forms, study them. Write them out over and over again. Create a flashcard. Create a Quizlet or find a Quizlet for those different forms. All right, we're going to skip the part from the book because I don't like their questions very much. Oops, I meant to take those out. So I'm going to give you just a little bit more practice. We just have 4 more of these. This is on the sheet that I passed out. Okay? I would keep my book out because we're going to use some of the information in the book in a second. Okay? So, I'm going to give you 2 minutes. Get back to your vertical surfaces, maybe 3. Let's get back to our vertical surfaces. And we're doing the same thing as we just did, determining the most efficient form you could use to write the quadratic function. Okay, so go back to your vertical surfaces, answer those 4. Which forms are we going to be using? Get them up on the board. And we might be able to use the same there. I have to go ahead and check it. But you will pull the same. You have a 10, yeah. You also didn't do it. So yes, you may do it.
Let me tell you, I need help.
What's up? Do we have a vertex? Yeah, do we have roots? Go back to your roots. Or go back to sit down. Once you wrap this up, you can start heading back to your desk. We should be there pretty quick.
Yeah. Hey, you want to do that?
What are you looking to do? All 4 of those, yep, that's all. Well, it's not just because there's only 2 points. What is one of those points? Well, what's one of the points that we have? And the maximum is a vertex, right? And guys, don't forget it's not just about writing down the final answer. It's about knowing why and being able to explain why. You need even
Once
know
you
what
get on that, you
That's fine, that's some evidence. Remember on assessments, the more you explain, the better evidence you understand. Well, the more that you earn. Alright. So let's look at these. I think everyone, from what I see, said vertex, factored, none, and vertex. Okay? So what keyword in number 1 told us to use, and by the way, don't forget it's vertex form of a quadratic equation. We do want to recognize that. So vertex form, the word is? Vertex. What keyword tells us to use factored form? Roots. Right? I have R1 and I have R2. Why none here?
There's no x intercept. There ain't no maximum.
There's no at least there, it may be, but they don't tell us that, right? But we don't have roots, we don't have x-intercepts. How do we know we don't have a root or x-intercept there? Not just because don't say it. Remember, to be a root or an x-intercept, the y has to be. So even looking here, there are no zeros for the y, so I know that I don't have x-intercepts. So can't use factored form. It doesn't tell me I have a vertex, so none. And then number 4, vertex form, because we see what keyword? Alright, so somewhere over here, and it looks like this, right? That maximum would be my vertex. Right? Questions, comments before we continue with actually trying to write some of these equations? Going once, going twice. We got like 6 minutes left. You'll be alright for 6 minutes. Okay. Because of where you are, I'm going to have you just work, stay seated for a minute. I just want you to look at number 1. Talk within your small groups for 60 seconds. Let's say 30 seconds. What form are you going to use for this number 1?
Vertex, because it's got vertex.
But it also has an x-intercept.
It says 2 x intercepts. But it's really.
Okay.
It's just 1 or 2 x, standard, right? Because there's only 1 of them.
Can we do factored if we only have one of them?
It's gonna be 1 of the 2 though.
But do we have the other one?
It's 1 of the, no. It's 1 of the 2 though.
So, let's talk about it, okay? So going factored, going, and I heard some saying vertex, and we're kind of split on this one. That's okay. You know what I would do to help personally me settle this and figure out which one it is? No, because I want you to learn how to think. All right, we got 5 minutes left. You know the first thing you should always do when trying to write the equation?
Write
Write out the equation, the formula, right? If I'm using vertex form, what is f of x equal to?
X minus plus k. And it's squared.
I need that square there, right? Hey guys, because this came up on your, what's up, Ted?
No, I feel like it's gonna be that form.
You think it's that form now?
Yeah, because like, it say 1 of the 2, so you can get that in there for the 2,
So,
It's a joke.
okay. If we use factored form, how many roots do I need for factored form?
2.
Do I have both roots?
No. So it's vertex.
I only have 1, so I cannot use factored form in this case. I have to use what? Vertex form. That's the thing to pay attention to, and this is why I would write that equation out. I will point this out. I can only solve an equation with how many variables? 1. Right? I can't have an unknown a and an unknown root. But when I look at this equation, and I have vertex, what symbols do we use for vertex? So I already know H and I know K. And what can I do with this 1 and this 0? Substitute for X and so 0, right? That's my Y or f of x is equal to, do we know A?
No, we don't.
We don't have A yet. What are we using for x?
Oh, it'd be plus 2
minus a negative 2, so plus 2.
squared plus, minus
So, and,
minus 9.
well, and I was gonna say, remember, if you add a negative, you can just make that easier and write
Minus 9.
minus 9, right? So you're adding a negative, which just becomes a minus. What are your questions about how we set this problem up? When you're talking, when it's x minus h, you do the opposite. But notice how it's a negative number, so it is minus 9. It's negative 2, so it became x plus 2. So, what are we going to do?
Well, I won that.
If they are not reporting to your TA assignment on their schedule, you are giving students, if you are giving students juniors or you seniors, you're gonna end up with ISI days and suspension days, so please report to your TA location. Thank you.
So, we're talking about these parentheses first. What are you trying to do if you're working within that set of parentheses? Right, but there's a mathematical term for that. It starts with an S. We're trying to simplify. Remember, I said I recommend to do what first? Simplify. A times 3 squared minus 9. Hey guys, come on now. I'm still teaching. Is there anything else I can simplify? So 3 squared is 9. I have nothing else I can simplify, so now is when I'm going to start using inverses. What am I going to do? I would say, can I do 9 minus 9? No, because that's being multiplied, so I can add 9, creating a 0. 9 is equal to a times 9. What's going to undo that multiplication? Division. I'm going to use the 1 divided by 9. 9 divided by 9 is? 1. This 9 divided by 9 is also? 1. So what is A equal to?
1.
So A is 1 times x plus 2 squared minus 9. There is that quadratic equation. We're going to finish up this sheet tomorrow. We're also going to go over the pre-assessment. Who all did I say I need to see during enrichment? So, I need Jose, no, not Jose, I need Naisha, Sanaya, Mickey, and Kim. I need your...
We're not going to make her date.
Are you able to come today? Are you doing your test today? Yeah.
Rob, look at your question.
Well, here's what I'm going to do. It's just a pre-assessment. So it's not a grade. Don't look things up. Just do what you can and give it to me first thing today. Okay? But come in and make sure it's okay.
Yeah, I don't want to go
Take the test, okay? So I'm not emailing you. Naisha, who do you have for enrichment? Doug.
I got it.
Wilkerson? Alright.
We're not going to be here next Tuesday.
I have no clue what words you just tried to say.
We're not going to be here next Tuesday.
Yeah, you should. You started out with all that.
I got so much work.
I understand, but also if you get behind in this class, that's going to hurt you more. It's not just trying to be an a-hole, it's like, I want you engaged, because one, you can help other people here learn, but two, you need to be engaged so that you, okay?
You guys want to teach them for kids?
Not yet, but yes. Say again?
Lots.
Yeah, every time we start a new lesson. Because I love it. And I just want to make my students miserable.
This is great.
These are the same groups you've been in, guys. We're gonna change up groups today, but not yet. Yes. Turn the heat on. I'll pray about it. Good morning, Mr. Kim. Good morning, Caleb. How you doing? I'm capable.
There you go.
You?
I am capable.
Good. Morning, Tristan. Yes, sir.
Morning, Tristan.
Good morning, Martavius. Say it again, Martavius. Say it like you believe it.
Nope.
Too bad. Say it like you believe it.
Okay.
That's at least a little bit better. Morning, Kason. Yes, sir. I just did it. Morning, Zaria.
Morning, Bruce.
Morning, Zaria. And
Morning, Bruce.